So now that we've talked a bit more about how you create streams, all the different myriad ways of making a stream, let's start talking about the aggregate operations that transform or filter or terminate a stream. And this will give you a deeper understanding of how all these different things work. So we'll start by just giving an overview, a recap of what an aggregate operation is. We talked about this much earlier on, but just for completeness. An aggregate operation is a so-called higher order function that applies a behavior on elements in a stream. And remember, a higher order function is just a highfalutin way of talking about a function that is either passed as a function as a parameter, passed a function as a parameter, or which could return a function as a parameter. In this case, we're passing a function of some kind as a parameter to each of these aggregate operations. And the functions that are passed are going to be functional interfaces, and they're typically provided in the form of lambda expressions or method references corresponding to functional interfaces. And common things that are passed would be function, predicate, consumer, supplier, and so on. These are some of the core functional interfaces. There are more, but those are some of the ones that are used most commonly. The great thing about aggregate operations, and this is true for streams in general, is they help to form a declarative pipeline that focuses on what you want done and pushes how things are done inside the framework. Of course, there's some how going on as well, because the behaviors correspond to how, but a lot of the nitty-gritty details of how things flow and are split and applied and combined and parallelized and so on are all under the radar screen. You don't have to care about how it works. You just have to know the effects. There are two types of aggregate operations. One is called intermediate operations, and these are used to process elements in the input stream that they receive and then yield an output stream. And some of the many examples, and there's many, many examples of these, are filter, map, flat map, take while, drop while, and so on. And we will talk about all of these, possibly not today, but we'll get through them soon. Interestingly enough, intermediate operations are optional in a stream. So you could have a stream that has a factory method to create a stream, and then you could immediately jump to a terminal operation, which we'll talk about in a second in more detail. Interestingly enough, and I'm putting this in here mostly because I got burned by it for a while and want to warn you in case you ever run across this. If you use a terminal operation like count with a method like peek, which is not supposed to have any effect on the items flowing through the stream, then the intermediate operation will be ignored altogether, which is very weird. And you can read about why. I don't really know why. I think it was a bug, but they changed the semantics. So newer versions of Java streams will optimize such that no intermediate operations will be called with count if they don't have some kind of actual perceived behavior that does something. And peek is something that's not intended to have a behavior per se. It's intended only to have side effects like debugging stuff and so on. So anyway, very strange. Just mentioning that as a side note. Don't think about it too much because we'll never run across it in what we're doing, but it is important to be aware of this. You can classify intermediate operations in a couple of different ways. And think of it like a fourfold table where you have an x-axis, which are run to completion and short-circuiting, and a y-axis, which is stateful and stateless. And then the various operations that Java streams define are binned into those different parts of that little matrix. Stateful operations store information from prior invocations on that particular stream for use in a future invocation. What the heck does that mean? Well, a good example of this would be sorted. We've looked at sorted before. So clearly, in order to sort a stream, you've got to have the state of all the other things that came up to that point. And so only after that will you be able to sort. So state is important. And there's a couple other ones as well. Take while, drop while, limit. Those are examples of short-circuiting operations. We'll talk about them shortly. And then distinct and skip are also stateful. Distinct, obviously, in order to make sure that the elements in a stream are distinct, you need to see all the elements in the stream to know whether they're duplicates, so you can ignore them. There's also another dimension here, which is stateless, which means there is no information stored from prior invocations that are required for subsequent invocations. And examples of this would be filter, map, flat map, and so on and so forth. Stateless operations are typically more efficient, both in terms of processing time and in terms of memory resources, and this is particularly true for parallel streams. So if you have a choice, you should try to go with the stateless ones. But that doesn't mean you shouldn't use the stateful ones. Just be aware that there may be some consequences of applying them, particularly with respect to parallel streams. Then there's also another dimension, which is this dimension, which is run to completion versus short circuiting. So run to completion says process all the elements in the input stream to completion, unless, of course, an exception arises. So we're going to pretend like exceptions aren't thrown when I have this discussion, because they short-circuit things in a whole other way, in a somewhat unexpected way. So all these operations here are run to completion operations. In contrast, these operations are short-circuiting, and that just means that you may only operate on a subset of the total available elements in a stream, but you may leave early. So limit would be an example of that. It says stop after you've seen the nth item. Take while, drop while, those are based on predicates that may eventually not be met, in which case the stream will stop processing at that point, or so on. We'll see how that works. So there are no short-circuiting stateless operations, but there are short-circuiting stateful operations. The other type of intermediate operation, the other type of operation or aggregate operation is the terminal operation. And these trigger the intermediate operations and typically, not always, but almost always produce a non-stream result. There's one weird little exception that makes the rule that we'll talk about later when we talk about parallel streams. So examples of these terminal operations would be for each, reduce, collect, find any, find first, and so on. Remember, a stream must have one and only one terminal operation. When I first started programming with streams, I would typically forget to put a terminal operation, and I'd wonder why my program didn't run. And then it's hard to try to put more than one terminal operation, but again, you can sort of do it kind of, but that's rare. It's more common to forget to put one at all. Terminal operations, like intermediate operations, can also be classified into several dimensions. And not quite as complicated, but one is run to completion, which means you just keep going until everything's processed in the stream. And that would include reduce, collect, for each, and so on. And then there's also the short-circuiting terminal operations, which may cause the stream to terminate before you process all the values. So examples of that would be all match, any match, find any, find first, none match, which will terminate when either a condition is met or not met, depending on what you're trying to do. So for example, if you say all match, then the first time the predicate returns false, the processing will stop. When you do your programming assignment 1A, you'll see that there's use of a short-circuiting terminal operation, although it's not as short-circuiting as it may seem because there's only one element that's coming out of the particular stream. But we use it in a way that is useful in the context of the example. So that is basically the overview of Java streams aggregate operations. Again, we will go in much more detail about these different operations later, but I wanted you to see the big picture view and the different types that they have.